Hi, I'm Dmitry.
And I'm Anton.
And we're at GeekOut in Tallinn, your hometown.
Yeah, in this post-industrial electric plant.
It looks very cool. You kind of see surroundings, so we're not in trouble somewhere, so it's all good.
Okay, we thought that we're going to show you a little bit of test-driven development, and we are going to implement a simple binary search algorithm using test-driven development.
Cool. And we're going to do ping-pong programming. Yeah. If you can manage Mac keyboards, though.
Yeah, that's really difficult for me.
So what we have binary search function, which takes an int array. Should we make it array of ints, though? I think that's maybe better.
Maybe.
Okay. Cool. So should we write a test then first?
Yeah. So the first obvious test would be to test an empty array, and
so what we should have like multiple tests for each case.
I think we will have one test method per case, like it usually should be.
Yeah. So we say find or search elements in an empty array. What should I call it?
Yeah. By the way, if you don't know what a binary search is, it actually looks up an element in an array of which is pre-sorted, which is faster than just going through all the elements.
Yeah, and empty array is a sorted array.
Yeah,
so
sure.
It works.
So let's assert that we get -1.
In an empty array.
Yeah.
Oh, that's funny.
That's a long test name.
Okay, empty array then.
That's, yeah.
Okay, so then I do binary search, then do empty array, and we need to do search an element, which is of type int. So we're searching for, let's say, 0.
Yep.
And
why
then
not?
we expect an index from it, I guess. And then we do assert equals, or what do you prefer? Equals is fine?
Let it be, it's simpler.
Yeah, so this is expected, which is...
So we expect -1.
But it will be I.
Yeah. I will also inline I. We don't need this variable, because we'll have many tests.
Yeah, so and I run this.
Yeah.
Well, annoyingly, it's just going to pass.
Unfortunately. Okay, then we need
It's your turn anyway, then.
Okay. Let me do a new test then. So let's find a single element. And we do an array of 1, and we are looking for... Okay, there will be 2 cases, not finding and finding, but let's do the finding. So otherwise it will be -1 again.
Yeah.
So I think the correct index would be 0. So let's run it. What's the shortcut? Yeah. So I think this one is going to fail. So yeah.
So I'm supposed to.
So now we have a proper TDD. Now you need to actually do something.
So am I allowed to do funny things, like saying if element equals 1, return 0?
You can.
This works.
That's not how you do coding in the real world, but why not?
Well, but still, okay. I think I'm allowed to do that. So, but that's not how you do it in the real world. So, am I supposed to write another test now, or are you happy with this hack?
Yeah, let it be. Yeah,
Okay,
write another test.
So, doing one more test then. 2 elements.
Actually, let's start with the middle. So the way how binary search works is that you pick the middle, and then you go either to the left or to the right. So the obvious next step is to actually have, for example, 3 elements and pick the element in the middle.
So it's just 3 elements.
Yeah, so we can go with the implementation.
So if we have an array of 1, 2, 3, and we search for 2.
Yeah, and when we get 1
3
back.
divided by 2 will be 1, so that's the middle element.
Yeah.
And that's what we're aiming for. So
Yeah.
it's 1. And this should fail the test.
Yeah.
Cool.
Nice. So now I would think that we need to, like basically, yeah, this is what we do. So we now look up the actual array. We go to the middle. So we take the array size divided by 2. And if this one is our element, then we return the index. Actually, that's extracted with the variable. So again, I have problems with shortcuts. So it's
Option V.
Or yeah. So let's do it like this, and we return I in this case. Do we need this one? Probably.
I think it will work. We can run it as it is.
Probably we don't. So let's run it. Oh, we failed the empty array.
Yeah, I guess we need to check for empty, right? Because we cannot.
Yeah. So actually, yeah. If we do the recursive algorithm, which I like, is that this is going to be a very important thing to check. So is empty, we return -1. And actually, yeah, this -1 should go, but for now it's probably okay. Yep. So it's nice. How do I get rid of the button thing?
Shift escape.
Okay, that's the same as in Linux.
Yeah, in Windows.
So now let's go and.
But can we add more things there? Or you think
Usually it's better to have different cases in separate test methods. So let's to the left of middle. Actually, I would rename this one in the middle because.
Oh, sorry, it's like IntelliJ is doing something clever, some new things.
In the middle. Okay. Basically, this test would work for any elements, like you
arrays of all sizes.
Yeah.
Check in middle.
Yeah.
Well, I guess more interesting would be maybe go for 4 because it's not clear what is middle when you have.
Yeah, but this is a more complex case now because you need to handle that. This is the most complex case for the binary search. So let's this one would be
3.
No,
2. Sorry.
So let's rerun it just in case. So yeah, it's still cool. And let's go for the left of the middle. So basically we look for 1 and we need to return 0. So this is something that we probably should not pass. Yeah. So keyword to you.
So basically we have else here and we say.
Yeah. So now we actually need to check if it's either smaller or bigger than the element, and then we should go either left or right.
So what we're saying is this: if the current element in the array, like mid element, is less than the element we're looking for, then element must be on the right.
Yeah, and I would
maybe it should be this, and we kind of flip. So we're saying element is to the left. That's what we did in our test, right? So that's what we want. Then currently this will work probably. Then we return and else we do that.
Okay, else if.
Yeah, sorry. So this might work.
Okay.
As a cheating thing.
Okay.
So
we can hardcode all the.
Is it like evil pair programming now?
Yeah, it is. Actually, it's good for demonstration always to remind you that if you don't have a proper test that actually checks that you really implement the stuff properly, then you can get away with hacking.
Well, that's not hacking. Also,
hard coding of the test data.
You code it to the left, and to me it wasn't like too clear. It's like just one element to the left or any element. To the left.
That's fine. Let's continue.
Maybe then I could write any element to the left of element or all elements. Oh, I'm not sure what you meant. You meant just.
Yeah, I meant that the correct element is to the left of the middle, so we need to actually go to the left. We need to continue searching to the left, but you can make it more complicated.
I could do it, let's say 1 in this case, and it will be 0, right? And this will fail.
Okay. Let me try doing.
Okay, cool.
So why not? Yeah, and in this case, I think we need to introduce the recursion.
Yeah,
so
sure.
that's. By the way, I still don't remember. Does Kotlin have the tail recursion?
Yes.
Does it have it already, or only
Yes.
the plans?
What? You're joking? No, it does. It does.
Okay, that's cool.
You,
So recursion is the best way to do here, and actually we need to.
what do you mean tail call optimization?
It's like if we do recursion, does it actually recurse, or the compiler will optimize it into a loop?
You can do both. Like,
Okay, there was something
yes,
like.
yeah, that's the thing.
Oh shit, yeah. But okay, let's see if it works. But actually now we can use a really cool feature of Kotlin, because when you implement this in Java, you cannot have default parameters. And with Kotlin, it's really convenient to do recursion with default parameters. So actually we need to introduce something like, basically we need to go through a smaller array and continue searching, like left portion of the array.
Yeah.
So actually we need to introduce something like start index, and that's going to be 0 by default. And we need to do the length, or like, let's do it size, like Kotlin calls it, and that's going to by default. Alright, mystic stuff. So by default it's going to array size.
Yeah.
So that's in this case we can just use the variable here. Now we cannot check for array is empty. Now we need to check for the size. So actually if size equals 0, then we are finished. And we go through, to take the half of it. Now we need to actually add something here. Our start, which is 0 by default. So we're now refactoring code. Hopefully we are not
probably
breaking.
we should have changed it back to I-1 kind of. Well, no, okay, let's do it. It feels like a very big step, to be honest. But.
It is, but usually with test-driven development, this is what you do. If you're like, if you're skipping the real implementation, then at some point you need to actually start doing the real thing. But this is just refactoring, actually. It's not not such a big step. So we have introduced some parameters, and now our test will show us if we have broken something.
Yeah.
And here we need to go back to the 0, but our size will be now smaller. So it will be half.
Well, then you should pass
half
start.
of the size.
You shouldn't have 0. You should have start then, right? Just pass it as it
yeah,
was.
that's correct. But for now, I think we're fine with 0 as well. But that's fine.
Oh yeah, you're right. For now it will go.
But we actually need to have that one as a size, as a new size. So let's extract it as a variable, and let's call it half size. So so this is something, and this is going to be an int. So yeah. So we will actually round it. Round it down. And you see, we haven't broken anything, and we have passed a new test.
Wow,
so that's
changed so much.
That's
That is so works.
yeah. But the good thing is that we have the tests that show us that we haven't broken anything so far.
Yeah.
So let's now go to the right. That's going to be more interesting, or like as interesting as this. So we'll look for 3, and we'll look for 5, for example. And 3 will be 2, and 5 will be 4. So let's run that, and it's going to fail. Yeah,
Nice.
great.
So let me just do some cleanup. I'll do this. It looks a bit nicer on the small screen. Maybe nicer. Not sure. No. Okay. So also do this. Leave return.
Yeah, that's
I'll run tests just to make sure.
That's the thing. If we don't have a
Least.
ternary operator,
They still fail in the same way. Okay, it wants
great.
when, but I'll do it later. So I guess the other case is that.
yeah.
Also, I feel like this.
I guess we don't need to check for it because this is the else condition. So we just drop the last else, which is useless.
Okay. So we do this, and then it will start at I+1 or not? No. No, it should be +1. That's an interesting thing.
Yeah, it should be +1 because we are looking for the don't want to look at the I again because we have just checked it.
Yeah, my concern is that if we have one element, which happens to be the middle, then we do +1, then we come here, and our size will be still
but
1.
we still need to create a test for it. So if
okay, I'm just not sure that's going to work necessarily.
well,
I don't expect it to work.
let's
Okay, I'll
try.
run it and see what happens. Okay,
Yeah, see,
everything
it
works.
Yeah,
Okay,
that's nice.
cool.
So now maybe we need
Let me
to.
do this thing. Still
Okay,
works.
now let's do more
it's formatting.
idiomatic Kotlin and stuff.
I'm not going to do it, but I like this format, and you can configure it so that it's aligned like that. That's nice.
Okay,
Yeah. Okay.
why not? And what probably now we need to create a new test.
Yeah,
So
but-
you were concerned with +1. So can you write a test that will fail it?
I was thinking actually just the thing I mentioned before, like what about this? We always had even
Yeah.
odd
Let's
number.
let's write a completely new test with the even number of elements because
Completely new.
Yeah.
I mean, why not? That's
because there is no middle in the even number of elements.
Okay.
So
Okay.
that's-
Fine. I thought there is a middle. It just depends on the definition of your middle. So here we say middle. Let's say what is going to be.
Let's create a new test
Three.
in the middle of even numbers.
Okay.
And in that case, we actually need to test for 2 cases because there are like 2 elements in the middle.
Even sized. Right.
Array, yeah.
Okay. Fair enough.
So let's
So
try
something like
this.
that, and then we're testing for 2 and 3.
Yeah.
Oh, I see. So 2 is 1. This is 2. 3. And then if we run this, let's see. Amazing.
Still passes.
Yeah.
Oh no. That's okay. We still. I'm pretty sure it's not the final implementation yet. So I think we may have problems with some. In these other tests, we have only looked either in the middle or at the end or beginning. So let's try somewhere in between.
I was thinking about making things more exhaustive. Like in the middle would include all these assertions. But okay, let's keep it like this.
To me, these are like different things, and I'm surprised that we are passing them. But
Yeah, me too.
but that's a good thing about test development. Sometimes you write a test, it works already.
Yeah. So can we add one more thing here because there is also this case. When we search
With
for 2, which is
with
left
even
of
numbers, there will be problems. Let's add tests that with even numbers we go to the beginning or end, because in this case the problem will be with actually deciding what is the half of the array that we need to search in.
But I'll just add a couple of cases here because it says right of the middle. In this case, we cover all elements, but in this case, we didn't cover 4. So
Okay.
I'll just add a couple more things. I'm sure they work.
Yeah, that should work.
Yeah, just for
Because
completeness.
with the odd number of elements, it's easy. But let's now. I think what we will be failing now. So let's continue with not the middle of even-sized array.
But
So
to the
let's-
left of
to the left of even-sized array. That would be more fun.
to the left of middle of sized array. It feels like we should have a couple of fixtures. Really, it's like one will be fixtures with odd size. Because now I'm wondering how are we going to group all these tests? They feel a bit ad hoc-ish. Okay, let's do it anyway. So we're searching for 1 in this case. Right?
Yeah,
And we
let's
expect
start
0.
only with this one. So don't rush with.
Still works. I think it's
Okay.
good. Our implementation is perfect. You're
Okay,
too skeptical.
but if we go to the end now, one of them should fail
to the
definitely.
right of the.
Yeah. Definitely, we should fail somewhere.
To the right. That's gonna be. I know bet it's gonna work. Don't be so negative.
Yes, yes.
Okay, but
I
you
knew
implement.
it. I knew it. So I think what we are missing is that when we're dividing the array, the problem is with this guy, because this is rounded down all the time because it's the integer division. And somewhere here, I think this half size shouldn't be right. So maybe it's correct when we go to the left, because we have passed this test. but it's probably not right when we go to the right. So probably
off by one thing.
yeah. So maybe like really like stupid idea would be to do something like that. I'm not sure if it will work. If the rest of the test, no.
Or minus then?
No.
Of the other one?
Yeah, let's think about it a little bit more. So, actually, which test did we fail?
We failed 2 now this time.
So it's to the right of the middle and to the right of the middle. Both of them. Okay, so that's not the right direction to go. But I know we need to do something with this half size. We're like missing some 1 here, so +1 or either -1 or something. Of course, we can. It's always easier to do if you are not recorded to do these kind of things correctly. Yeah. So when you're giving like a presentation talk, you always miss some really simple thing. To the right of the middle, even size right. We are actually now we are failing both to the right of the middle.
But I did half size.
Yeah, and half size and yeah, if we're taking +1 here, it should be somewhere. It should be -1, no? Like the logic says. Yeah,
Wow,
that's the solution.
Wow, yeah, that was fascinating. Okay. So
These off by one errors are hard in programming.
yeah, true. I think there is like one other thing that can be difficult to do is like if you have like a list of size of max int type of thing. There is like one more tiny thing to add, but yeah, otherwise it should be just fine. Cool. I don't even know what I learned from this. I guess off by 1 thing. And TDD was good. I haven't done it this way. I really liked the way you structured tests. It was really interesting.
Yeah, we can group them now, actually, also, if you want, but maybe it's
well, they are grouped
not
in some way, right? They go like empty, single, middle of even sized. For symmetry, I would say then of odd sized. Right? Maybe that would make.
But I would say that definition of middle is only possible for the odd sized array.
It depends on what. I don't know. It's like, to me, it depends on your definition of middle.
But anyway, binary search is much easier with odd size than for me. Like when you're like progressing step by step, it makes sense to implement the simpler case first, and then you like find a solution for a more complex case. And you do step by step, and you can write any code like this.
Yeah. Well, in the end, I guess you just thought really hard and you knew the answer. Cool. I guess we can stop here.
Yeah. Thank you for watching.
Thank you. Bye.